Okay, here we go with 7.7. Let me share the notes. Greetings from Palm Springs. Um, okay, so let's do a little warm up. But in 7.7, we're going to be factoring special products. So remember when we multiplied out, if we had a binomial like x plus 1 quantity squared, and we knew exactly what that pattern would look like, square the first term, double the product, two terms, square the last term. Well, now we're going to go the opposite direction. Instead of multiplying out, to simplify, we're going to factor, right? We're going to go with the reverse way. So that if we saw something that fit a pattern, we're going to be able to factor it a quick way without having to do the old-fashioned method or star method. Okay. All right. But why don't you have some fun trying this warm up? Pause the video. Notice that you're going to put digits 0 through 9. So there's 10 blanks. But I'm going to tell you right here, those numbers form a 2-digit number. Okay. Those digits form a 2-digit number. All right. Give it a shot. Okay, I'm back. So let's see. Did you have, let's get these. I like this one. I thought this was fun to do. Okay. And, probably best place to start, or I mean, there's different places that you could have started, but realize like here would have been one, right? We know it's got to be whatever I put right here squared, that's going to get me the 49. So I know that's going to be a 7. And I also know that if this is -1, whatever it goes here times here is, and it's a difference 2 squares, so it's got to be a 1 and so forth. You can go from there. Okay, now go ahead and practice, again, the fast way of multiplying out these binomials squared. Square the first term, double the product of the 2 terms, square the last terms. Okay, pause, do it. Okay, so hopefully you got x squared plus 2x plus 1, 4x squared minus 28x plus 49, because remember, the product of the 2 terms is -7 times 2x, which is -14x, and then we're multiplying that by 2, so we get -28x. And this one, we just have 16x squared minus 72xy plus 81y squared. Okay, all right, and then here's some practice that you can do on solving by substitution. So try those. Okay, so obviously if you have x is 2, you can just plug in 2 for x in the top equation. And once you do that, you just have one variable here to solve for. And then you solve for it and you get y equals 1. And then obviously we know x is 2, so our answer is 2, 1. Okay. This one, notice how y is equal to both of those. So you could have substituted in 4 plus x for this y, or -3x plus 8 for this y. Either way, you would have gotten either this equation or that same equation that just the two sides switched. And then when you solve for x, hopefully you got 1. And then what would you need to do? Plug in. Yeah, either one's pretty easy. Top one's pretty simple to do. 4 plus 1 is 5. So we think our answer is 1, 5. I would then probably go maybe to the bottom equation, plug in both. So does 5 equal -3 times 1 plus 8? Yes, because -3 times 1 is -3 plus 8 is 5. 5 equals 5. Check, check. Okay, our learning target here is to recognize and factor special products. Again, this is the goal here is to make for some really efficient, quick factoring where you don't have to use the star method or the old-fashioned way. All right, so let's do a little work here. You can work with me again, or someone else in your house maybe. You're going to use algebra tiles to write each polynomial as the product of 2 binomials. Check your answer by multiplying. State whether the product is a special product that you studied in section 7.3. Okay, so we know that you've got to make 4x, or I'm sorry, x to the 4th, because these are each an x squared. So it's not x to the 4th, 4x squared, sorry. And whatever goes here and goes here also has to get me a positive 2x and a negative 2x. Okay, so maybe you would start by going like this and like that, right? That would work. And then positive 2x times what would get me to positive 2x? Yeah, plus 1. And then to get over here from positive 2x times what would get me negative 2x, that would be negative 1, right? So negative 1 times 2x is negative 2x, and then does the last work. Positive 1 times negative 1, negative 1. Okay, so what is that factor to? This is 2x plus 1. This is 2x minus 1. Are those special binomials? Is that a special product? Yeah, they're conjugates, aren't they? First term's the same, second terms are opposite. So the answer is yes. Okay, now try 4x squared minus 4x plus 1. Okay. Again, we got to get 4x squared. Okay. This time I notice that the last term is positive. So it's positive there, but here it's negative. Oh, what does that mean our signs need to be? Yeah, negative, negative, huh? Okay, so hopefully you got that. And then, oops, didn't mean to get rid of that, but that's okay. Should have gotten 2x minus 1, 2x minus 1, which we would write efficiently as 2x minus 1 quantity squared. Okay, is that a special product? It sure is. It's a binomial squared, right? All right. Oop. Yeah, it said yes under there. All right, I got rid of that before. Okay. Here's some more that you can try. So try these on your own and pause the video. All right, I'm back. Hopefully you got 2x plus 1 and 2x plus 1, which means we could write it as 2x plus 1 squared. Is that a special product? You betcha. It sure is. Okay, now try 4x squared minus 6x plus 2. So hopefully you got 2x minus 2 and 2x minus 1, or vice versa, right? 2x minus 1, 2x minus 2. Is that special product? Are those conjugates? Are those the same binomial squared? No. Okay, so again, that's what we're going to be doing. We're going to be going from, again, we're going to be factoring. We're going to be taking a polynomial and breaking it down to its factors, looking for special cases. And here's this first special case. This is the difference of two squares pattern. Okay, so again, we're just going reverse order. Earlier in the chapter, we went from a plus b, a minus b to recognize that it's a difference of two squares. Now we're going to start with hopefully recognizing it's a difference of two squares, and then immediately factoring it to a plus b, a minus b without any of our longer methods. So can you write this as a difference of two squares? Well, of course you could. And I'm not saying you have to do this step necessarily, although it might be helpful in some situations with more challenging ones. But isn't x squared minus 25 the same as x squared minus 5 squared? Isn't that a difference of two things that are squared? So we write it as conjugate binomials, x plus 5, x minus 5. Okay, what about the second one? Is 4, obviously 1 is a perfect square, right? It's 1 squared, and it's a difference. Is 4z squared something that we could write as something squared? Yeah, 2z quantity squared, right? Okay, so then how would you break this down into conjugate binomials? 2z plus 1, 2z minus 1. And again, remember, you can check just by multiplying out. All right. So why don't you go ahead and try these? Pause the video. Okay, I'm back. Hopefully you got x plus 6, x minus 6. This one, 10 minus m, 10 plus m. A lot of times people ask, well, couldn't I just put m minus 10, m plus 10? And the answer is no, because that would get you m squared minus 100, which is actually the opposite of 100 minus m squared, if you think about it. So in this situation, you got to have the m's last. Okay, how about this one? Yep, you could write that as 3n quantity squared minus 4 squared, which means we could, our binomials or conjugate binomials would be 3n plus 4, 3n minus 4. Okay, and then hopefully on this one, you got 4h plus 7, 4h minus 7. All right, these are awesome. Let's see if we can do these in our head. Remember, this would be what? How could we write this? Well, it's a difference of two squares, isn't it? So couldn't we write it as 3x minus 34 times 3x plus 34? And what's great about these are real easy. You can do that in your head. That's just 2. That's what? 70. And 2 times 70 is 140. Okay. All right. So what would you do with this one? Yeah, same thing. 47 minus 44, 47 plus 44. Again, not that bad to do in your head, right? 3 and 91. 3 times 90 is just 27 with a 0 in the end, aka 270. And 3 times 1 is 3. So our answer is 270 plus 3, which is 273. Okay. All right, try these two. Okay, I'm back. So you got 5 times 105 and 4 times 52. So 525 and 208. Okay, difference of 2 squares. All right, so this is a good, if you want to take a break, this would be a good time to do it because we're going to get into the next set of, special pattern trinomials that we can factor quickly. So this would be a good time if you want to take a break. All right, let's keep going. So here is the perfect square trinomial pattern, or perfect trinomial square, as I sometimes call it. So we remember these. Remember, if we had something in the form of a plus b quantity squared, that always multiplied out to the first term squared, a squared. Multiply the 2 terms together in the binomial. So positive b times positive a is positive ab, and then multiply whatever's there by 2, 2ab, and then square the last term. Okay. And also same thing if it's minus. It's just there's a minus there. It's the only difference. So same thing here, right? If we recognize that something is in this pattern of first term or something squared, and then 2 times the product of the square roots of those, then we know it's going to factor to just the square root of that plus or minus the square root of that. Minus being if it's a minus sign there, okay? So the questions you ask yourself, are the first and last terms squares? And is the middle coefficient, double the product of the square roots of the first and last terms? Okay, so let's look at an example here. X squared plus 6x plus 9, okay, is the first term a perfect square? Yes. Is the last term a perfect square number? Yeah, 3 squared, right? Is the coefficient here on our middle term equal to the square root of this, x, times the square root, one of the square roots of this, 3 or negative 3, doubled? Yes, because 3 times x doubled is 6x. So then we know it factors to the square roots of those, x plus 3 squared, okay? Only difference here is we're going to say is negative 6 equal to the square root of this first term times one of the square roots of the last term? Yes, because negative 3 is a square root of 9. It's one of the real roots. And negative 3 times x doubled is negative 6x. So we know we can rewrite that as just x minus 3 squared. See how fast that is? Okay. All right, so let's try it with these ones. Go through these questions. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. 4 squared, right? Or right, negative 4 squared. Those are the 2 real roots, right? Is 8, positive 8, equal to the square root of this times one of the square roots of that, doubled? 4 times n is 4n doubled is multiplied by 2, 8n. So yes. So what does it factor to? N plus 4 quantity squared. Okay. Okay, what about this one? Is the first term a perfect square? Yes, 2x times 2x, so 2x quantity squared. Is the last term a perfect square? Yes, 3 or negative 3 quantity squared. Is one of the square roots of this times the square root of this, 2x, doubled equal to this, negative 12? Let's see, is negative 3 times 2x, which is negative 6x, doubled equal to negative 12x? Yes, it is. So how can we write it? 2x minus 3 quantity squared. Again, how do you check these? Yeah, you multiply out. First term squared, 4x squared. Double the product of the 2 terms. Negative 6x doubled is negative 12x. Last term squared, negative 3 times negative 3 is positive 9. Okay. So again, this is a way of speeding up the process. All right, on these first, go ahead and try these first two, okay? And again, remember your first step is always to look for a GCF. Okay, but try the first two and then we'll do the third one more together. Okay, hopefully on this one you did realize that it is a perfect square trinomial, right? And this factors to m minus 1 quantity squared. Okay, what about this one? Yes, d minus 5 quantity squared. Okay, now on this one, notice that we do have a GCF we can take out. So you always, 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 wait, what did I say? Dr. Kalin, what did I say? Did I say always? Always take out the GCF first. What's the GCF of 9, 36, and 36? Yeah, 9. Great. What's left inside the parentheses? Z squared plus 4z plus 4. And now your life just became a lot simpler. Is that a perfect trinomial square, a perfect square trinomial inside the parentheses? First term of perfect square? Yes. Last term of perfect square? Yes. 2 or negative 2 squared is 4, right? Is the product of one of those square roots, 2, positive 2, times square root of z squared, z, doubled equal to 4z? Yes, it is. So it's going to factor to 9. Don't forget that. A lot of careless mistake is to forget to bring that GCF down. And then z plus 2 squared. Okay. All right. Now we are going to step it up even more. Notice here, and everything up to this point, we have not solved an equation. Now we're going to solve an equation. So now we're, again, getting back to using the zero product property, right? So we always got to make sure that this is set equal to 0. Standard form set equal to 0. Then factor, is there GCF? No. Okay. So then let's ask ourselves, is it a perfect trinomial square? Is it? Is this a perfect square? Yeah, x times x. Is this 1/9? Yeah, 1/3 times 1/3, or negative 1/3 times negative 1/3. Is one of the square roots of 1/9, 1/3 or negative 1/3, times the square root of this, x, doubled, equal to 2/3. Let's see, well, positive 1/3 times x is 1/3 x, doubled would be 2/3 x. So it is. So we could write that as, that would be another way of writing it, right? That's just showing that it is in that format of a perfect square trinomial. So we can rewrite it as x plus 1/3 quantity squared. Now we still need to solve it, right? So we want to set each factor equal to 0, but in this case, aren't the two factors the same? Aren't, one of them's parentheses x plus 1/3, and if I wanted to write it out, I could write another parentheses x plus 1/3 since it's squared. So don't bother doing it twice, just do it once, and we get negative 1/3. Okay, or you could have done this. If you didn't want to deal with the fractions, you could have multiplied everything by the least common denominator, which in this case would be 9, because 3 goes into 9, right? So you could have multiplied everything by 9. Notice that would have gotten me 9x squared, 6x, and positive 1, because the 9s would cancel, equals 0. And then you could go through that whole same process. Okay, it's a trinomial. Is there a GCF to take out? No. Okay, is it a perfect square trinomial? Yes, it is, because first term could be written as 3x quantity squared. This is 1 squared. Square root of that times 3x doubled could get us to the 6x. Okay, and then once we have it like this, again, you're not going to do it twice, and you get x equals negative 1/3. So either way would work. Here, those of you that are more comfortable with fractions, great. If not, multiply by the least common denominator, get rid of your fractions, and then go to work. All right. Okay, so why don't you go ahead and try this first one here? Go for it. Okay, I'm back. Hopefully you said, yeah, it is a perfect square trinomial because that's 3 squared, and that's a squared, and 3 times a doubled is 6a. So then I just need to set one of the factors equal to 0 because they're both the same, and I get a equals negative 3. How do you check it? Yeah, it's an equation you plug back in. Negative 3 quantity squared is 9. 6 times negative 3 is negative 18. So I have 9, negative 18, and 9. Does that add up to 0? It sure does. Okay, on this one, Go for it. And now I'm back. This one is definitely a little bit more challenging, but hey, again, just follow the steps. Is there a GCF? No. Okay. Is the first term a perfect square? Yeah. Is the last term a perfect square? Well, it's positive, so that's good. That's a good first step, right? Can't be a negative to be a perfect square. 49 over 36. Oh, yeah. Isn't that just 7 over 6 quantity squared? So it is, right? And notice that negative 7 over 6 times W would be negative 76W. But if I multiply it by 2, I get 7/3, right? So, and this, again, in this case would be negative. So that makes sense. So I can rewrite it like this, set each factor, in this case, just one of them because they're the same, equal to 0. And then W equals 7/6. Okay. All right, what about this last one? GCF? No. Oh, it's not even a trinomial, so I don't have to worry about perfect trinomial square. It's binomial. What kind of binomial is this? Difference of two squares. So remember that factors are what kind of binomials? Conjugate binomials. So we get plus or minus 9, or negative 9, doesn't matter how you write it. I like plus or minus, it's more professional, quicker. Okay, awesome. Oh, I love this. I was just watching a golf tournament on TV. A bird picks up a golf ball and drops it while flying. This has actually happened, by the way. The function represents the height, y, and feet of the golf ball t seconds after it is dropped. Okay, so y is height above the ground, right? And time is seconds, t. Okay, the ball hits the top of a 32-foot tall pine tree. Okay, well, does that tell you something? What does it tell you about the initial height? Yeah, it had to be higher than 32 feet, right? This is, it dropped, right? It dropped and it hit the top of a 32-foot tree. This is not where the bird flings it up in the air and it goes up and hits the top. Dropped it, okay? After how many seconds does the ball hit the tree? And we have this equation here, y equals 81 minus 16t squared, okay? So what's true of the height of the ball if it hits the ground? Zero, good. What is the height of the ball when it hits the top of the tree? 32 feet, right? So wouldn't I want to figure out what time is, because this is what it's asking, after how many seconds, time, does the ball hit the tree, when the height, y, is 32, okay? So now what do we need to do? We need to solve for t. And how have we learned to do that? It's a quadratic equation, right? We have something squared, so what do we need to do? We've learned one way of doing it. That's using factoring and the zero product property. So we need to get it set equal to 0, okay? So let's do that. So I'm gonna do what? Subtract 32. And if I subtract 32 from 81, oh, I get that wonderful 49 number. We love 49. Okay, so now we have a binomial. So you're gonna ask yourself, is there a GCF that I can take out? And the answer is no. The factors for 16 are, well, 1 doesn't really help us in any way, does it? Or 2, does 2 go into 49? No. 4 does not go into 49. And then I'll, obviously 8 doesn't either. So, and 16 doesn't. So then we're going to say, is it it's a binomial. So is it a difference of two squares? And it is, isn't it? Yeah, 7 squared minus 4t quantity squared. So what would this factor to? 7 minus 4t, 7 plus 4t. Remember, as you go, you can always check by multiplying out. Okay. We're going to set each of those factors equal to 0. So 0 equals 7 minus 4t. 0 equals 7 plus 4t. Solve each of these for t. And we end up getting, you should get, plus or minus 7/4, right? Because on this one, we're going to subtract 7, divide by -4, and get positive 7/4. In this one, I'm going to subtract 7 and divide by +4 and get -7/4. Okay, so what does that mean? It means the time is either 1 3/4 or -1 3/4. But does a negative time make sense? No, of course not. You can't have a negative time. 0 is when it's in its mouth. It's going to drop. It's going to be a positive. Okay. And would it make sense that there would be 2 answers? No, it's not going to drop and then, go back up and then hit it again. So our answer is what? Yeah, 1.75 or 1 3/4 seconds. Generally, you want to put 7/4 seconds. And when it's a word problem, you want to make it a mixed number, something that's more easily understood. Okay, what if the golf ball does not hit the pine tree? After how many seconds does it hit the ground? Well, I already mentioned, what would y be if it hits the ground? Yeah, 0, good. So you just set y equal to 0 and solve it. Okay, so we already know how this is going to factor, right? We know that it's going to be, except instead of where we had the 49, we have an 81. Okay, so what does t equal? Plus or minus what? 9/4. Again, does a negative time for the ball to fall make any sense? No. So what's the answer? 2.25 or 2 1/4 seconds. All right, and now an exit ticket. I want you to factor those 2 polynomials, and I'll give you a hint. Obviously, with there's being only one box there, they are special pattern ones, aren't they? All right, go for it. All right, hope you saw this is the difference of 2 squares, and you got 9 minus x, 9 plus x. And here, hopefully you realized 12 times x, or -12 times x doubled, equals -24. This is a perfect square trinomial. So what does it factor to? X minus 12 quantity squared. All right. And I believe that does it with 7.7. Only one more section to go in chapter 7. Way to go. And we'll get to that real soon. See you later.